Hey guys, this is Mr. Yo, and today what we're going to talk about is ratio and proportion and similar polygons. Now, the procedure of how I usually do things, especially with videos, is that I will go over some concepts and provide you guys practice problems. Now, if I'm going too fast, please make sure to pause the video and rewind back to where you missed the informations. And there will be some practice problems where you might have to pause the video and then try to work on it on your own, and I will provide you the answers after you press play. So, here we go. There are a couple topics that I do want to talk about, which are property of proportion, similar polygons, using ratio to write equations, and then there's going to be a homework assignment which is located in Schoology. So make sure to do those assignments. And if you guys can do it online, type the answers and send it through email or give me a hard copy. Either one's totally fine. But here we go. So, what is proportion? Proportions are a set of two or more fractions equal to each other. So, within this proportions, there are two types of properties. One is called the cross products property, while the other one is called equivalent form of proportions. So I'm going to go step by step of each topics and then give you guys some practice problems. Cross product property. What is that? Basically, its two fractions are cross multiplying. Keyword right here. Cross multiplying. But the denominators cannot be zero. Okay? Because what happens if the if the denominator is zero in a fraction? Well, it becomes an error or undefined. So, in this case right here, we have a over b equals c over d. What I'm trying to tell you is that if you have a fraction equals a fraction, what you can do is cross multiply. So b goes to c while d goes to a. And by doing so, this will provide you the information of a times d equals b times c. Now, if you don't understand why this is happening, here's an example. If I draw, let's say, a over b equals c over d, I'm going to try to get rid of the denominators in the fraction by multiplying by b first. Now, the order doesn't matter, so I'm just going to start out with b. So a equals bc over d. Next, I'm going to multiply d on both sides. And by doing so, this will give you AD equals BC. Same exact thing that is happening right there. And if you guys don't want to put the multiplication sign, just use AD equals BC. That is totally fine. And that should help you guys out with cross products property. Okay, so always remember cross product, cross multiplication. Next, we have the equivalent forms of property. Now, there are three properties within this form. One is property 1, which showing that C and B and B and C, they can switch places. It doesn't actually have to be right there. So as you can see, the B is flip-flopped with A and C is flip-flopped with D. Either way, it will still give you the same answer. That's pretty much what it's trying to show you in part property 1. Now in property 2, you can actually switch diagonally. For example, we can switch to C and B and C, just like this. Either way, the answer will become AD and CB or AD and BC. Okay? It still gives you the same answer as you solve this problem. Now, for property 3. Now, property 3 is not something that I usually recommend as much. because we're not going to go over much of the problems with this property. Basically, what I was trying to show you is that the denominator is being added. So adding corresponding terms. So like I said, we're not going to actually go over this property 3 as much, so I'm just going to skip that one. So now, let's try to solve some problems. Now, if you guys want to pause the video before moving on and look at the answer key, feel free to do so. All right, so let's try to solve the first two questions. Right now, we have 2, which is going to cross multiply with 3 minus x, and 6 to x. So what's going to happen? It's going to be 3 minus x parentheses 2 equals 6x. Now, always, 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 whenever you're solving these problems, simplify as much as possible, okay? So if I were to solve this out, remember the 2 distributes, and that will give you 6 minus 2x equals 6x. Now, make sure the like terms always stays with itself, stays together. So I'm going to add 2x on both sides. By doing so, you get 6 equals 8x. Now, we can also divide this by 8 because we're solving for x. So if we do so, x is equal to 6 over 8, but you can also simplify it by dividing it by 2. So it becomes 3 over 4. And that will be your answer. Okay? Now let's go on to the next problem. The next problem is pretty much the same. You'll do the same crisscross applesauce or crisscross multiplying, cross multiplying. And this will give you 10 times y minus 5 equals 4y. It distributes, so it becomes 10y minus 50 equals 4y. And I'm just going to make sure that the 10y goes to the 4y. The order does not matter. Either way is totally fine. Okay, and that will give you negative 6y. If you divide negative 6 on both sides, okay, that should give you a wrap or things up to get 50 over 6, which is also 25 over 3. Okay, so it's just simple math calculation. Now, if you're struggling with it, please make sure to go over the notes again or ask me questions or send me an email of what is the problem that you're having or struggling with this concept. Okay, so that is your answer, 3 over 4 and 25 over 3. Next, so we talked about proportions. Now we're going to talk about ratios. Okay, so ratios, sometimes we call it A colon B, can also become a fraction of A over B. So let's try to understand by solving a problem. It says the ratio of the length of the length to width in the rectangle is 4 over 7. So what's happening right now is that if we look at 4 and 7, the 4 represents the length, while the 7 represents the width. So everything that is written here are chronological order right here. Okay. So if we have the length of 14, so I'm just going to write the same thing that we have done with proportions. If we talk about length and width, then obviously the next one would be length and width as well, because we need to make sure that we solve this in orderly fashion. So if our length is 14 that is given, what is our width? So you can call it as x, but I usually like to call the first letter of the question, which is W. So the information says the ratio can become a fraction. So 4 colon 7 is the same thing as 4 over 7. And 14 colon W is 14 over W. Just make sure to crisscross applesauce. And once you solve this out, you will get 4W equals 7 times 14. Okay? And what is 7 times 14? That will give you around, okay, 98. And last but not least, I am going to divide it by 4 on both sides. Okay? Now, it's your choice if you want to leave it as a decimal form or a fraction. Now, if I was to put it in a fraction, it's going to look like this. Let's see. Oops. Let's see. 49 over 2. Or you can write it as 24.5. Okay? Usually I like to put units in the answers because that's basically how math works out. But in this case, since we do not have any units, we're just going to leave it as it is. Okay? So that's how you figure out the ratio problem. If you go over to the next slide, it tells you the answer. So feel free to look over my work. And if you have any questions, just ask. That's all. Now, let's go on to similar polygons. Now, similar polygons, there are two concepts you must understand. Congruent angle, and if you guys don't know what congruent means, which you guys should know it, means the same. And proportional sides, okay? Now, the symbol that we use for similar is kind of like a squiggly line, as you can see right there. And then next we have the scale factor. So scale factor is basically a ratio of the corresponding sides. I'll show you more about this in our first example on the next slide, but make sure to keep these notes with you when doing so. So we need to do a couple of things. We need to talk about the similar statements or similarity statements. Okay, that's the first one. Number 2, we need to talk about its proportional statement or proportionality statement. Okay. Number 3, we're going to talk about the scale factor. And that's what we're going to do. So those 3 things we're going to perform right here on this slide. So number 1, how do we talk about that these two triangles are the same? Well, the first thing I will do is that I'm going to put a triangle symbol on 2 sides. Okay? Because we're talking about the similar triangle in this case. And I'm going to make sure I have a squiggly line right there. Now, it doesn't matter where you start, but wherever you start, that should be the point where the other triangle or other shapes must start as well. For example, if we're going to start out with an A right here, that corresponds to H in this case. So I'm going to put A and H. Next, if I'm going to choose C, then that means we're going to use T. Okay, C and T. Last but not least, I'm going to put a B and an R. Now, if you guys are kind of confused, how in the world or what did I do to get this similar triangle? Well, what I've used was the angles that are provided here. As you can see, we see an angle that has 3, a 1, and a 2. 3, 1, and 2. So I was following those steps to find out where is the similarity happening. Okay. So, now that we talked about the similar statement, let's talk about the proportionality between these two. Okay? So, if we talk about proportionality, let's talk about, let's say, the sides. So, if we talk about triangle A over B to triangle HTR, okay? If we're going to put in this format, what we're going to do is first we're going to start out with a side. So let's say A and B. Now A and B is located right here. Which of the side on the other triangle is similar to that? Well, if we remember, we have A and B here. That means we're going to look at H and R, which is located right here. So I'm going to make sure I put H and R, which is equal to, if we use the next one, which is B and C, okay, I'm going to use a blue color, B and C right here. Then I'm going to follow with the R and T, just like that. Okay. Maybe I should have used a different color. Whoops. So I said B and C. Okay, perfect. Now I'm going to go on to the next side, the last side, which is A and C. So I'm going to put A and C on the top, and I'm going to put H and T on the bottom. Okay? So this way we can actually figure out which sides are similar to which side. Now, there's two ways to do so. One way is this. Another way you can actually write this down is when you put triangle HTR on the top and triangle ACB on the bottom, which is basically the same thing. All that's happening is that the denominator will change to a numerator. Okay? And that's how we figure out the proportional statement. So make sure that you draw or bold or do whatever that can help you mark which side will be the same to which side. So now that we talked about that part, let's talk about scale factor. A scale factor is basically we're talking about is what is it being multiplied by? Okay, so for example, if we look at AB, so let me choose a different color, AB and HR, okay, what are the values? Well, if we look at AB right now is 1.5. But what is HR then? That is 3. Now what we're going to do is we're going to simplify and solve this out. So if you plug this into the calculator, you would get 0.5, okay, or 1/2. So that means whatever we're dividing, so if we did the AB and HR, if you go into BC and RT, that will also give you the solution of 1/2. Same goes with AC over HT. Okay? And that is the reason, or that shows why this is a similar triangle or similar shape. Now, if we go on to the other side, just like what we just did, if we do HR and AB, then that basically means that instead of 1/2, it will be 2. So even though the scale factors are slightly different, it does not matter. The only thing that matters is that one side, so if we check on these, they all must equal to 2. That is the most important thing about this similar polygon or similar shapes. Now, if that makes sense, let's go on to the next part. If it doesn't make any sense, please make sure to go back again, think about what I just said, and try to think it through. So here's the answer to this statement. If you guys want to have a more visualizable answer. Okay. Now let's move on to the next part. The next part, it gives you two triangles, and it wants you to figure out the following. Write the statement of proportionality, find the measurement of angle R, and find AY. Okay? So it's the same exact thing what we just have done with the other ones. So for example, let's see. So in this case, we have, well, it says FRI. So I'm going to put the numbers down to make it visible. RI. Next, we have DAR, IY. So what I'm going to do is, based on those numbers, I'm going to pair it up. So I'm going to have FR on the top. That means I'm going to have DA, same as FI and DY, which means RI is same as AY. And there you have it. So that is your statement of proportionality. Now, if we look at measurement angle R, okay, if we're solving for that, we know angle F and D are going to be the same thing because similar triangles or similar polygons have the same angle or congruent angles. So we have 58 on top and 61 on the bottom. Now, as you know, the total angle of a triangle is 180 degree. So make sure to subtract that to 58 and 61, and that should sum it up to a 61 degree after you solve it out. Okay? So make sure to know that the angles provided are the same or congruent to the angles on the other triangle in this case. So now that we know how to do this, what we're going to do is we're going to find AY. So we need to first know the scale factor. So how we're going to do, or what we're going to do, is I'm going to use FR and let's say DA. Okay? And if we're looking at AY, then what is, so RI is corresponding to it. So if we solve this out, we know FR is 3, and we know DA is 12. If we solve it out, that is 1 over 4. So that also means that RI and AY has to equal to 1/4. But we already know what RI is, which in this case is 5. Okay. So all we're going to do is crisscross applesauce, and that will give you AY equals 5 times 4, and that gives you 20. And that gives you the answer to this question. Okay? All right, so using this as an example, well, there's the answer. Using this as an example, try to solve the next question. Now, this is a different scenario, but similar situation. Okay? So pause the video and try solving those questions. All right. So in this case, what we're going to do is that I'm going to mark out the triangles. So right now, we can see that there are 2 triangles. One here and another one right here. Okay? Just like how the question stated. So what we're going to do is write down the proportionalities. So I'm just going to write down the proportionalities if you guys already have tried to do it. So it's SH over SP equals HA over PE, SA over SE. Now, if we look for angle SHA, so SHA, we're looking for this angle right here. Now, we know that it has to be congruent, so SHA is the same as the angle, angle of SPE, which in this case is 77 degrees. Okay? So use your surroundings to figure out the answer. Okay? And also, if it's better for you guys to draw a separate triangle, that is fine too. For example, if we do SAH, 3 centimeters, and then a bigger triangle, 77, 60, EP, 12, 20, and S. So if you want to separately draw this out, that is totally fine too. Okay? So now, find SH and HP. So SH, what is that similar to? Well, we know that is similar to SP. Now, that has to equal to, let's see, with the given numbers, we have HA and PE. Okay? So if I were to rewrite this down, SH is what we're looking for. SP is 20. HE or HA is 3, while PE is 12. So all I'm going to do is make sure that these all equal to each other. So we have 1 over 4. So if I crisscross it, just like how we did it on the previous one, I'm going to make sure it becomes 4SH equals 20. But we're just looking for SH, so I'm going to divide it by 4. So SH is equal to 5 centimeters because the unit is given here. So SH is equal to 5 centimeters. Perfect. But what is HP? So we're looking for this section as well. Well, we just figured out this section is 5. So if I were to solve that out, obviously overall is 20. But we want to subtract by 5 to get 15 centimeters of HP. Okay? And that's how we figure it out. So if you guys have any questions, just try to get used to this because a lot of problems are going to be repetitive over and over and over. Same setup of how it's done. So make sure that you get used to these kind of problems. There's one more to this, and we will go over one last lesson for today. Okay. So now, if we have a triangle that is kind of flip-flopped, okay, what I'm going to do, well, first is that we're looking for a measurement angle M. So we're looking for this angle. How do we figure that out? Well, this triangle right here is pretty much a flip-flop of this triangle. Let me show you what I meant by that. If I were to redraw the triangle, okay, if M is here, L is here, and N is here, Q is here, I believe that's Q, and P is here. Okay, so what I'm going to do is I'm going to make sure I have all the angles and sides written. Okay, and there you go. So if we look at letter M, that is pretty much the same as Q in this case. Okay, so that means we know this angle will become a 36 degree right off the bat. And if we look at ML, measurement L, well, measurement L in this case is right here, and we don't even know what it is because we don't have P. Okay, but how do we figure that out? Well, we know angle measurement L is the same thing as angle P. So let's try to solve for P then. or L. So if M, we know it's 36, the total angle of a triangle is 180. All you got to do is subtract 36 and 106 to get your overall of 38 degrees. Okay? So always make sure that you know the total angle of a triangle is 180 degree. Okay? Next, let's solve for MN. So we're looking this time for this one right here. But wait, we already know a proportionality between these two triangles. For example, if we have MN, that's similar to QN is equal to. Now make sure to use the one side of the fraction must have all the numbers. So in this case, M and L and Q and P. And we have MN, which is what we're looking for. QN is 20. ML is 33 and QP is 30. So I'm going to make sure that I cross multiply. Okay. And that will give you MN, well, 30 MN equals 20 times 33. So that should give you, well, let's divide it by 30 on both sides. Now, if you calculate this, you will get the answer of 22. Okay? I hope that's not too complicated, but if it is, please do ask questions to me so that I can help you guys out. Okay? And there you go. So one last thing I want to talk about is ratio in equation. What I meant by that is ratio can be a fraction, but also you can write it into an equation, just like as you can see over here. But it must find a total of something. So for example, if you look at this example on the bottom, it says the measure of an angles are in the extended ratio of 3, 4, 8. Find the measure of the smallest angle. Well, first of all, we know a total measurement of total angle of a triangle or a three-sided figure is 180 degree. And in this case, it gave you three numbers, 3, 4, and 8. So what does that basically mean? What we got to do is make sure that we have an X located right here, okay? So that means every one of these three numbers is going to be multiplied by its common factor. So if we add this up, let's see, that should give you about 15x equals 180. If we divide by 15 on both sides, your x is going to equal to, well, not 3, it will equal to 12. So now that we know x is equal to 12, we're specifically looking for the smallest angle, which in this case is the one with the smaller ratio. So 3, if we bring it here, 3 times 12 will give you a total of 36 degrees. Okay? So this is what I meant by having ratio in an equation. If this is still confusing to you, try to solve other example problems provided in Schoology, and also ask me questions during class or through email. So good luck with your study. That is all for today. So hope you guys have a good one, and I'll catch you guys later.